We're constantly told to optimize. I mean, we live in this relentless pursuit of efficiency.
It's everywhere.
Right, whether you're refactoring old code, streamlining a corporate process, or even just trying to declutter your own calendar, the goal is always the same.
Eliminate friction.
Exactly. Reduce steps and clear away anything that looks like, unnecessary overhead.
But every so often you run into that one thing.
Oh, yeah. Every professional knows this feeling. It's that weird manual review step or that ancient line of code that nobody dares to touch.
Or that one company rule that just seems completely pointless.
And you just wonder, why is this even here? But what if that single strange element is actually the load-bearing pillar holding the entire structure up?
What if removing the one thing you don't understand causes a just spectacular and catastrophic failure?
Today, we are taking a deep dive into the philosophy and the devastating reality of that exact risk. We're analyzing a principle known in tech circles as the Doorman Fallacy.
Which has its roots in a much older idea, a concept called Chesterton's fence.
And it's really a concept that demands a kind of intellectual humility from anyone who's trying to make a change.
It does. The core idea of Chesterton's fence is, on the surface, deceptively simple. It just says you should not remove a fence or alter a rule or change a tradition.
Until you know why it's there.
Until you fully and rigorously understand the reasoning behind its initial existence. It forces you to stop and just be curious about the past before you act.
So our mission today is pretty straightforward. We're going to unpack that original metaphor, look at how this exact fallacy destroyed an ancient sailing vessel in the middle of the Atlantic.
Wow.
And then dissect why it is probably the #1 overlooked vulnerability in complex interconnected systems, especially in, modern IT. We're exploring what happens when efficiency blinds you to necessity.
I like that. Blinds you to necessity.
To really get the power of this idea, we have to start at the source. It comes from the writer G.K. Chesterton in his 1929 book, The Thing.
That's right. And Chesterton's original metaphor, it's just the perfect setup. He describes coming across a fence or a barrier that's been put up across a road for seemingly no logical reason.
Okay.
The instinct, he argues, especially for what he calls the modern reformer, is to immediately say,
I don't see the use of this,
right.
It's ugly, it's in the way, let's just clear it away.
Exactly. That's the impulse.
And that impulse is really rooted in a kind of, intellectual arrogance, isn't it? The assumption that if the function isn't immediately obvious to me, a smart modern person, then it must be useless.
That's the trap. The more intelligent, or let's say, the more rigorous approach is to recognize that someone in the past actually spent energy and resources to put that thing there.
Right. They had a reason.
They had a reason, a wisdom, or some necessity that was guiding them. So the reformer's job, their first job, is to investigate, to find that original function.
So you have to understand why the fence exists.
Only once you have that full knowledge, only when you know precisely what purpose it serves, good or bad, are you actually equipped to decide whether to change it or get rid of it.
The core practice is just due diligence.
It is. Researching the historical context, the original constraints that led to the structure you see today.
And this applies to so much more than physical fences. I mean, we're talking about legacy business processes, rules, legal precedents.
It's all the same principle. You're guarding against these rash reforms that has huge unintended consequences just because someone didn't bother to ask why.
Which brings us directly to the modern business framing of this idea.
The Doorman Fallacy.
Yeah, and this scenario is so relatable. Imagine a luxury hotel and management decides they need to cut costs. They want to replace the highly paid human doorman with a new state-of-the-art automatic sliding door.
The math seems simple.
The cost-saving rationale looks airtight, right? They look at the doorman's job and they conclude his only function is opening the door for guests.
And a machine can do that.
A machine can do it faster, more reliably, 204/7, and it doesn't need a salary or benefits. It's an immediate win.
But that simple functional analysis is the fallacy. They're reducing the entire role to its most basic, visible physical action. The open door function.
And they're ignoring everything else.
Everything. The massive, diffuse, and often unquantifiable value that the human fence was providing.
So what is the doorman's actual job?
Well, the actual job is customer service. It's greeting a high-value guest by name. It's providing immediate localized security by, noticing who's approaching the entrance.
It's flagging taxis, managing traffic flow.
And adding that subtle layer of prestige that literally defines the brand as luxury.
So when they remove the doorman, they don't just save money on door opening, they accidentally increase their security risk, they decrease their brand prestige.
And they diminish the overall guest experience, which down the line means reduced profitability and real reputation damage.
The total cost of removal is way bigger than the perceived gain. It's a systemic cost, not a simple salary saving.
Exactly. You've optimized a visible cost center by outsourcing one physical action. But you lost an entire ecosystem of value and risk mitigation that was embedded in that one human role.
Okay, let's make this even more concrete. Let's turn this from philosophy into a literal life-or-death engineering failure. This example of Thor Heyerdahl is it's perfect.
Thor Heyerdahl, right, the explorer, famous for the Kon-Tiki. He undertook 2 expeditions, RAY in 1969 and then RA2 in 1970.
And he was trying to cross the Atlantic.
In boats made entirely from papyrus reeds, based on ancient Egyptian tomb paintings. He wanted to prove that ancient cultures could have made these huge oceanic voyages.
So for the first boat, the RAI, they followed the designs they found in this ancient art.
Meticulously. But in the design, there was this specific continuous rope. It wrapped around the entire length of the papyrus bundles.
Okay, I can picture that.
But to them, it just looked aesthetic. It seemed like excessive binding, and they couldn't figure out its structural purpose. So they decided
would omit it. The fence was the rope.
The fence was the rope. They looked at it and thought it was superfluous, inefficient, unnecessary for their modern, improved version.
And what happened when that boat actually met the open ocean?
The structural integrity it failed. Immediately.
Wow.
The papyrus gets like a sponge when it's wet, but the real issue was the dynamic stress from the waves. Without that continuous external binding rope, the individual bundles of reeds just started to work themselves apart.
So it was a progressive failure. It didn't just snap.
It was. As the bundles separated, the vessel started taking on water, losing buoyancy. And critically, the stern of the boat began to sag, like severely into the water.
Huge stability issue.
Massive. They had to abandon RAI just short of Barbados. The whole expedition failed because they eliminated one single, seemingly redundant part.
And the fix for RA2, the second attempt, wasn't some new technology.
No, the fix was intellectual humility. For the second boat, they didn't just rebuild. They went and found the traditional knowledge they'd ignored.
They put the rope back on.
They included the continuous binding rope. And, crucially, they hired boat builders from Lake Titicaca in Peru. People who still possessed the generational knowledge of how to build these boats.
And those builders knew why the rope was there.
Instantly. They knew it wasn't decoration. It was the mechanism that distributed the stress of the waves across the entire hull, preventing the bundles from shifting and breaking apart.
And the RA2 made it.
The RA2 successfully completed the crossing. The lesson is that traditional knowledge often represents centuries of hard-won engineering wisdom. It's the reason for the fence.
That brings this philosophy right down to the database layer. I mean, if a failure can be that immediate and that physical, where is this fallacy hiding in the non-physical systems that run our world?
Let's shift to the architecture of security. That's where the Doorman Fallacy causes absolute chaos.
Okay, so let's go back to our corporate setting. An IT team decides to replace an old but secure legacy single sign-on gateway.
The SSO gateway, yeah.
And they want a new self-service portal for requesting elevated security privileges. The old way required all these manual sign-offs.
Oh, the old system was slow, it was clunky, everybody hated it. You had to email a form, a manager had to approve it, then an admin had to manually process it.
And that administrator was the human doorman.
That person was the doorman, checking the request against HR records, against the authorization matrix, a real human check.
The new system, though, was designed for zero friction.
Right. It was a web form, you submit it, and it sends a request directly to the access-granting API endpoint, and the crucial omission, the thing they missed,
Was the gatekeeper.
they failed to build the gatekeeper function into the new technical architecture.
Wait, so you're telling me the new technical solution was just assuming the old manual human approval step would somehow still happen?
Precisely. They optimized away the human admin step, but they completely forgot to enforce that same verification step at the API layer.
So the original doorman was responsible for verifying who was asking?
And if they were authorized to ask, the new system just assumed that if the request was properly formatted, if it looked right, it must be valid.
They created a massive architectural flaw, an authorization bypass vulnerability.
That is a huge failure of risk modeling.
Yeah.
If you remove the only human element checking identities, and the new system doesn't do that check digitally, you've essentially created your own zero-day vulnerability.
And that's exactly what happened. A disgruntled employee, or maybe an outside attacker, discovered that the API endpoint would accept any properly formatted request for admin rights.
Without checking who sent it.
Right. Without verifying the requester's identity against the directory or the SSO authority, they didn't have to hack the system.
They just had to mimic the format of a valid request.
So it wasn't a hack, it was a structural oversight. They forged the parameters, sent the request, and were instantly granted system-wide admin rights. Why?
Because the technical fence was missing?
And the damage.
Catastrophic. With those credentials, the attacker installed keyloggers on the finance servers and siphoned off months of sensitive payroll data.
And the initial review blamed human error.
Of course. The security team that should have caught the forged emails later. But the root cause was the Doorman Fallacy. They optimized away a tedious manual check that was, in reality, the only functional security gate in the whole process.
That is fascinating. It's a direct line from the hotel doorman being the single point of human scrutiny to a missing API call that should have authenticated a user.
When you optimize the doorman out of the system, you have to rebuild that scrutiny digitally. And this happens everywhere, not just security.
Give me another example.
Think about an old database table. It has a seemingly unnecessary primary key constraint, or a foreign key relationship that forces some strange, slow data entry process. You might decide it's inefficient and just remove it during a refactor.
Assuming it's just, historical baggage.
But often, that constraint, that fence, is the only thing preventing massive data corruption. Or maybe it's preventing resource contention by forcing a specific, slow, but safe, right order.
And if you remove it for efficiency?
Suddenly, your whole system is brought down by resource exhaustion during peak hours because you accidentally introduced a critical race condition.
So what does this all mean for someone listening? We've gone through history, physics, IT architecture. The core lesson seems to be, before you touch that annoying, complex thing in your job,
you have to understand its purpose. Fences are not random. They represent historical efforts, complex trade-offs, decisions made by people who understood constraints that we may have forgotten.
The key is informed change.
You have to know exactly what value, what function, what security you're about to lose.
So for someone listening who works in a technical field, how do you spot a functional fence in a sea of actual technical debt? How do you know what to leave alone?
I'd say look for areas of surprising latency or counterintuitive design. Ask why. Why does this particular process take 3 manual steps when it could be 1 click? Why is this ancient piece of code still running?
And the answer is often risk mitigation.
Almost always.
Yep.
That slowness, that extra step, might be the very thing that prevents errors in a process that would otherwise crash half the time.
Well, we should address the counterpoint here.
Right, the traditionalist fallacy. Chesterton's fence is a guide to intellectual humility, not a dogma that says never change anything.
There are times when a fence just needs to go.
Absolutely. There are instances where you can't find the original reason, or the fence is actively causing demonstrable harm. Maybe it's enforcing an outdated or unjust process. In those cases, it has to be removed.
And in those really complex cases where you have no history but you have to move forward, the source material suggests something called the scream test.
The scream test is a high-risk measure, though. It's a last resort. It means making a tiny, low-risk change, removing one picket from the fence, so to speak, and then watching the whole system very, very closely.
To see if anyone screams.
Exactly. If nothing critical breaks and nobody complains about a loss of function, you proceed with extreme caution. But informed knowledge is always, always better than that kind of high-risk guessing game.
So before you try to modernize or streamline anything in your professional life,
Whether it's a complex spreadsheet formula that runs your budget or a company policy everyone hates, ask yourself one critical question.
what purpose, what security function, or what hidden value might this structure be providing that I am currently overlooking?
That's the key.
The core lesson is one of accountability, isn't it? When you remove that fence, you inherit the historical liability it was managing.
That's a great way to put it.
If you remove that legacy code or that manual step and the system fails 3 months later, you're not fixing a bug. You're correcting an act of, historical vandalism. Before you propose a change, you have to be willing to sign your name to that potential liability.
So here's a final thought. Reflect on something in your work right now that you see as tedious or irritating or just plain inefficient.
And instead of just scheduling its removal, what is one specific piece of due diligence you could do? One conversation with a long-serving colleague, One deep dive into the system's commit history.
That you could do to discover the original reason for that fence before you propose any change. Go find that knowledge.
That's the true power of informed change. Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.